Hey guys, welcome back. Welcome to Vedantu's JEE channel, everyone. How are you all? So, guys, it's been a long time that we have been studying the chapter of current electricity. All my students who are aspiring for JEE 2021, that means next year's JEE, I welcome you all. Welcome back to Vedantu's JEE channel once again, guys. Today we are starting a new chapter. We are entering into the unit of magnetism, and the name of today's session is Motion of a Charged Particle in an External Magnetic Field. Okay, so all my students who are usually fascinated by the concept of magnetism, the time has started. Okay, so guys, as usually there are many students who are first timers who are new on the platform. Let me start off with my introduction. So guys, this is me, your Suri Sir. I'm an alumnus of IIT Bombay, and on this channel I'm known as Mogambo. Yes, why am I called Mogambo is because when you will crack this examination of JEE, Mogambo khush hoga. And if you are new on this platform, then probably you would want to know what is the schedule that we follow for JEE or NEET 2021. So guys, every day at 9 p.m. like this one, we meet for carry discussion of physics, chemistry, and math. And on 3 days in a week, at 8 p.m. we meet for MCQs discussion. Okay. Also, let me introduce you guys to your teachers as well. This is Harsh sir. He is your chemistry guru. This is Arvind sir. He is the master teacher for mathematics, and this is me, the master teacher for physics for all of you guys. Okay, guys. So I hope all of you are aware that on Vedantu, we don't just have our YouTube platform channel, but we also have our own specially designed platform where students prepare for not just JEE or NEET. Students as young as 5th standard till 12th standard study for various different examination. Okay, so let me start off with sharing the success story of last year, that is 2019. So guys, last year was amazing for us because we had 7 students making it to the top 10 all India ranks, sorry, top 100 of all India ranks of JEE Advanced. Yes guys, top 100 is the dream for any student or any institute to have students cracking it. Okay, we were fortunate to have 7 such students who made it to the top 100 ranks of JEE Advanced and obviously made it to the best of the IITs. Some of them are Sumit and Chirag. Along with that, we have Nivedya, worth mentioning name. She got All India Rank 697, currently studying in IIT Bombay. Not just that, guys, we had 35 students who made it to the 99 percentile club of JEE Main, and 20 students got selected for KVPY as well. Okay, not just that, in 10 standard board examination in CBSE, we had 56 students who made it to the 95 percentile plus elite club. Okay, not just that guys, the Vedantu app on Play Store, which you can also download if you have not, it is one of the best apps, education platform apps on the Play Store as far as our country is concerned, with the rating of 4.8. This is, I think, the platform which you can use, especially in the time of pandemic, to continue your any preparation of any examination. Not just that, guys. On Vedantu platform, students are studying from different states, different cities, and actually different countries also. Over 500 plus cities have students who are studying on Vedantu's platforms. That's the global reach which Vedantu has as of now. So far on Vedantu's platform, we have delivered 11 lakh plus hours of live teaching. I'm not talking about the recorded one, I'm talking about the live teaching. And around 9.5 lakh students or more than that have studied so far and prepared for different examinations. So guys, I don't think you need any more reason. If you are now interested to be a part of this awesome platform, then that possibility is what I'm sharing with you all with the subscription plan which we call as Vedantu Pro. On Vedantu Pro, you get live interactive session, study material and assignments for your preparation, and a lot of test and your own performance analysis. So this is not just the only thing that you get on the platform. Apart from that, what makes it really worth having a platform on is that with Vedantu Pro subscription, you can study from any teacher of your choice at any given time. Yes, guys. whenever the lectures are going on Vedantu's platform with Pro subscription, you have unlimited access to any of the courses of Vedantu. In fact, not just that, you can select the language in which you want to study, be it Hindi or English. And later on, when your preparation syllabus wise gets completed, you naturally become a student who gets enrolled to the test series, and all the micro courses are also accessible to you. Okay, guys, let me show you how exactly the platform looks like. So this is how the platform looks like. The platform is what we call as wave platform. Yes, this is not a lecture which happens on any video conferencing app. It is Vedantu's own platform. Okay, guys, this is how a teacher delivers a lecture. This is Pulkit sir teaching a group of students. This is where students are able to interact with themselves, among themselves, and with the teacher also. And this is where they are able to ask their doubts. Okay, and this is basically a concept explanation happening, and not recorded, but a live interaction. Okay, people. So if you are interested in joining Vedantu platform under this subscription plan, then all you have to do is follow this link available. The link is available in the description of this video. Okay, when you will click on that link, guys, you will be directed to the Vedantu's homepage, where you will have to select your standard and the examination that you are interested in preparing for. When you are done with that, you can choose different subscription ranging from monthly, quarterly, half yearly, or annually. Obviously, as you move to a longer subscription plan, the per month cost obviously will be reduced and will be less and will be very light on your parents' wallet as well. Okay. So initially, maybe if you want to give it a try, you can go for a monthly subscription, try it out, and later on you can jump to a longer subscription. It actually going to cost you, if you go for an annual subscription one, it will cost you around 75 rupees per day. That reasonable the course is. Okay, people. Not just that, guys. If you enroll right now, an additional 15% discount can be availed by clicking on this link and using this coupon code. Okay, what's the coupon code? It is SM Pro. By using this code on any of the subscription plans, you get 15% additional discount. Okay, guys, don't worry. The sessions are definitely happening on YouTube as well. This is an additional feature which students who can afford it and who are interested in taking their preparation to a next level, they can definitely take an advantage of Vedantu Pro. Okay, people. So if you are on the YouTube channel for the first time and haven't done it yet, then do subscribe to the channel. It's free of cost, definitely. And press the bell icon so that whenever your Suri Sir comes live, you get the notification. Okay, people. So as I said, we are starting off with the unit of magnetism, and today the very first topic and the very first session of that topic, where we are going to speak about charged particle moving in an external magnetic field. We will speak about later on how magnetic field gets created. Don't worry. As of now, we are considering that magnetic field exists and a charged particle is going to enter in that magnetic field. So what will happen with it? For that, I think you guys remember in electrostatics, whenever a charged particle was entering into an electric field, it was experiencing a force which we used to call as the electrical force. So here, if your charged particle enters into a magnetic field and if it experiences a force, means what? If we find that the charged particle is accelerating, then we can say that it is experiencing a magnetic force. Okay. Unlike electric field, here there is a possibility where the charged particle may also not experience any magnetic force. I'll tell you how and when that is going to happen. First of all, the force, the magnetic force, the formula for the magnetic force experienced by a charged particle which enters with a velocity v in a magnetic field B. Yes, B is the symbol that we use for the magnetic field. So when your magnetic field is B and the velocity v is the velocity of the charged particle which enters in it, the force that your charged particle is going to experience will be found by using cross product, which means what? The force is going to be mutually perpendicular to the direction of magnetic field as well as to the direction of velocity vector. Okay, guys, and the formula which you will have to remember, if possible, please do remember this formula. We are going to use it in many questions in general related to the magnetism part. It is given by q v cross b, where q is the charge of particle Okay, guys, it's the charge of the particle. V is the velocity of the charged particle, and B is the external magnetic field. The units are called Tesla. Okay. Yep. So guys, the formula for the force which is experienced by a charged particle is given by Q V cross B. Okay. Now, if we are interested in finding the direction, as I have already said, that it is a product of, or it is the result of cross product. So definitely the right hand thumb rule will come handy over here. If I will rotate velocity vector towards the direction of magnetic field vector, then the direction of thumb of my right hand will point towards the direction of magnetic field. Okay, guys. So with that, we'll be able to find out the direction of magnetic force by using the right hand thumb rule. Okay. Also remember, this is the direction of force on positive charge. If your charge particle is negative, then the direction of force will be negative. Okay, this will be the force on negative charge. Remember that. Why? Because for the negative charge, the magnetic force will be minus QV cross P. Okay, guys. Awesome. Also, if you want, you can use one more rule which we call as right hand palm rule. I'm telling you that also. So for right hand palm rule, we will use our fingers as the direction of magnetic field. The direction of velocity will give you the direction of thumb will give you the direction of velocity, and face of the palm will give you the direction of force, and back of the palm will give you the direction of force on the negative charge particle. Okay, so fingers are magnetic field, thumb is the velocity, face of the palm force on positive charge, back of the palm force on negative charge. Okay, don't worry, with example we'll see that as well. Okay. A visualization for all of you to see here the way a charged particle is going to move in a magnetic field. So this dot is telling you that the magnetic field vector is coming towards you and velocity is perpendicular to it. When that happens, the force is perpendicular to velocity and magnetic field both, and that's how the charged particle is experiencing a force. Definitely, you can see that if your magnetic force magnitude wise is F equal to QVB sine theta, then F will be maximum when sine theta is 1 and theta is 90 degree, and F minimum, if you look at, guys, it will be 0 when sine theta is 0. Okay, guys, which will happen when theta is 0, which means what? For this to happen, your velocity vector and your magnetic field vector should be perpendicular to each other, and for this to happen, your velocity and magnetic field vector should be parallel to each other. Okay, so as I said, there is a possibility that a charged particle may be moving in a magnetic field but still not be experiencing a magnetic force. For that, the velocity and magnetic field should be parallel to each other. Okay. Okay, now if we have both magnetic and electric field present simultaneously and a charged particle is moving, so far when the charged particle was stationary, we were talking about electrostatics, so the force only which was acting was electrical force. But now what is happening? You have a magnetic force QV cross B and QE as the electrical force acting on the charged particle. This net force which acts on a charged particle when it is present in a region where simultaneously electric and magnetic field are present, the net force will be called as the Lorentz force. Okay, guys, I don't think any difficulty should come here because it's simple vector addition which is going to be used in order to find out the net force which is acting on a charged particle. Okay, guys, cool. So based upon this small theory part that we have studied, let's have a look at some examples here. Okay, guys. So first question, it says that an electron is moving along positive x-axis. Okay, a negative charge is moving along positive x-axis, and a uniform electric field exists towards the negative y-axis. So you have an electron which is having a electric field which is acting towards negative y-axis. Okay, if that is the case, then the force which will be experienced by the electron will be obviously towards this direction. So this is the direction of electrical force. Yes, guys, because electron experiences a force opposite to the direction of electric field. Okay, everyone. Now, question says that if the charged particle is moving along this direction, this is the direction of its velocity, then what should be the direction of the magnetic field of suitable magnitude so that the net force on the electron comes out to be zero? So if net force has to be zero, then definitely the magnetic force acting on the charged particle should be along negative y direction. That's all we know here. So if you have velocity in this direction and magnetic force we want in this direction, then we have to use the right hand palm rule. Okay, but on electron. Okay, guys, that means back of the palm is facing downward, and the velocity vector is towards the positive x-axis. Use your right hand, guys. Your thumb should point towards the velocity direction, and here we will use the back of the palm because it is a negative charge, so it is pointing towards downward. So the fingers are pointing inside the screen. That means what, guys? The direction of magnetic field comes out to be, if this is your x-axis, this is your y-axis, then the one which is going inside is negative z-axis. Okay, guys, I hope you understood. First, we needed to understand that the electric force will be along positive y. So in order to make it move continuously along net force to be zero and continuously move along x-axis only, the force from magnetic field should act along the negative y direction. For that to happen, right hand palm rule used, the thumb giving you the velocity towards x-axis, back of the palm pointing downward towards negative y-axis. So the fingers are pointing inside, which is negative z-axis. Okay, guys. Okay, now this says that we have a proton which enters in a magnetic field of flux density 2.5 Tesla, which is nothing but your magnetic field only, with a velocity of 1.5 into 10 to the power 7 meters per second at an angle of 30 degree with the field. So we have to just find out the force on this proton. Okay, so one thing, the charge on the proton is something that we should know, 1.6 into 10 to the power minus 19 coulomb. So the force is going to be QVB sine 30 degree. Charge is 1.6 into 10 to the power minus 19. Velocity is 1.5 into 10 to the power 7. Magnetic field is 2.5, or we can say it is 5 by 2. And sine 30 is also 1 by 2. So I have 1.5 into 1.6 into 1.5 multiplied by 5 will make it 7.5 divided by 4 into 10 to the power, this is minus 19 plus 7, that makes it minus 12. So guys, what do we have here is this cancelling it 0.4 times, and we have 4 into 7.5 into 10 to the power minus 13, right? I made it 4. So 4 into 7.5 is going to be 30 into 10 to the power minus 13, or we can say it is 3 into 10 to the power minus 12 Newton, the force which is acting because of the magnetic field and the charged particle moving in it. Okay, guys? Cool. Moving on to the next one. This question says that we have a 2 mega electron volt proton which is moving perpendicular to the uniform magnetic field at of 2.5 Tesla. So what is the magnetic field force on the proton? So first of all, this thing, as we know, is mega electron volt. Electron volt, if you do not know, is the unit of energy, and mega electron volt is 10 to the power 6 value of the electron volts. So if I try to write down the kinetic energy which is given as 2 mega electron volt, to convert it into joule, first of all, mega is 10 to the power plus 6. Okay. Micro is 10 to the power minus 6, by the way. This is 10 to the power 6. And electron volt, if you want to convert it into joules, you will just multiply it by the charge of electron. So now the energy is in joules. So the kinetic energy, which is half mv square, has become 2 into 1.6 into 10 to the power minus 13. Okay. So half into mass of a proton, which is 1.6 into 10 to the power minus 27, is equal to 2 into 1.6 into 10 to the power minus 30. So what we see here, guys, this is into v square also. 1.6 gets cancelled. I have v square, which is equal to 2 into 2. This 2 also went there, into 10 to the power minus 13 into 10 to the power 27. So v square is 4 into 10 to the power 14 is what we are getting. So the velocity comes out to be 2 into 10 to the power 7 meters per second. Okay guys, so now we have the velocity and it is moving perpendicular to the magnetic field. So the force is QVB sine 90 is 1. So charge is proton's charge is 1.6 into 10 to the power minus 19. Velocity is 2 into 10 to the power 7 and magnetic field is given to us as 5 by 2. So 2 and 2 I cancel and I have 1.6 into 5, which is 8 into 10 to the power minus 12 Newton. Okay guys, comes out to be our answer. Okay, moving on. Next question says that a charged particle is projected in a magnetic field. Magnetic field is given to us. Acceleration of the particle is given to us. We have to find the value of x. So guys, we know that the magnetic force is perpendicular to the magnetic field and force is nothing but mass into acceleration, right guys? That means acceleration should also be perpendicular to the magnetic field if force is perpendicular to the magnetic field. And whenever we have two vectors which are perpendicular to each other, their dot product should be equal to 0. Yes or no? So if we have these two vectors, their dot product should be equal to 0. And for that, I can say that ax into bx plus ay into by should be equal to 0. So ax is x, which is unknown, bx is 3, ay is 2, and by is 4, and this equated to 0. I'm not writing this 10 to the power minus 2 here because any which way on the right hand side when it will go, it will become 0. So I have 3x, which is equal to minus 8, and x comes out to be minus 8 by 3. So if we look at the options, the correct answer comes out to be option B. Okay, guys. Cool. Next one. This says that a charged particle moves through a magnetic field which is moving perpendicular to its direction. Then what can we say about its kinetic energy and momentum? So it says that you have a charged particle which is moving perpendicular to the direction of magnetic field. So maybe this is the direction of velocity, this is the direction of magnetic field which is pointing inside. So if I use my fingers along the direction of magnetic field, velocity is pointing towards the direction of velocity, thumb is pointing towards the direction of velocity, magnetic field is going inside, then face of the palm tells you that the force is going to be acting perpendicular to both of them. This is the direction of force. Now you can choose any direction of magnetic field, by the way. I'm just taking it as an example here. So what I'm trying to tell you that the charged particle is likely to change its direction, right? But because force is acting perpendicular to velocity, so we are sure that the speed will remain constant. Speed will not change. Why will speed not change? Because the force acting on the charged particle is perpendicular to its uh, velocity, and the velocity itself is perpendicular to the magnetic field here. Okay guys, so we can say that if speed is constant, then the kinetic energy will also be constant. But as the direction of motion is changing, then we can say that momentum is not going to be constant. So if we go by the option, it looks like option B, which says that the momentum changes but the kinetic energy remains constant, is going to be the right answer. Okay guys, next one, this says that a uniform electric field and a uniform magnetic field are acting along the same direction in a certain region. So we have a magnetic field and we have an electrical field acting in this region in the same direction. If an electron is projected along the direction of the fields with a certain velocity, that simply means what? The velocity is also in this direction only, which means what? The angle between magnetic field and velocity is 0 degree, which means sine theta is also going to be 0, which means what? The magnetic force is going to be 0 for sure. So what are the options that we have about the velocity? It says that the velocity will increase, velocity will decrease, the body will turn, the charge particle will turn towards left, the charge particle will turn towards the right. So guys, if you have an electron and the electric field is here, so first of all, electron will experience a electrical force in this direction, which is opposite to the direction of its velocity. So definitely it is going to retard, and electrical field will not change its direction because it is acting along the direction of its velocity. So only the velocity of the particle will reduce because of deceleration, or which is caused because of the electrical force. Magnetic force is any which way 0. The only force acting is electrical force. Okay. This one, this says that a particle of charge minus 16 into 10 to the power minus 18 coulomb moving with velocity 10 meter per second along x-axis enters in a region where magnetic field is along y-axis and electric field of magnitude 10 to the power 4 is acting along the negative z-axis. So if the charge particle continues to move along the x-axis only, the magnitude of magnetic field should be how much? So particle enters along x-axis and continues to move along x-axis, which simply means the magnetic force is balancing the electrical force, which means QVB is equal to QE. Okay guys, as it is moving along x-axis and magnetic field is along y-axis, so they are any which way perpendicular, so we can say it is QVB sine 90, right? So Q gets cancelled. We are supposed to find out the magnetic field, which is going to be E by V. So electric field is given as 10 to the power 4, velocity is 10. So magnetic field very simply comes out to be 10 to the power 3 Weber per meter square, which is a new unit for us. You can also consider it simply as Tesla. Okay, guys. So our answer is option A. Okay. Now this one, this says that a proton moving with a constant velocity passes through a region of space without any change in its velocity. So if there is no change in its velocity, that simply means QE should be equal to QVB. Okay. That means electrical force is equal to the magnetic force. So if E and B are representing the electric and magnetic field respectively, then the region of space may have, definitely it may have non-zero electrical and magnetic field, and the other possibility is also there that both of the electric and magnetic fields, both of them are zero, so your charge particle will enter and will continue to move in a given direction. Right guys? For charge particle to not change its velocity, there are only two possibilities. Either there is no electrical or magnetic field, and if they are, then definitely they must be non-zero and they are cancelling out each other in terms of the forces. But the possibility B and C cannot be there, because if only magnetic field is there, then the charged particle may have its direction changing and a force acting on it. And if the electric field is non-zero, then definitely there is going to be some acceleration. Okay, guys. Now, this one is your homework question, everyone. Try to find out the force acting on the proton when you have magnetic field, velocity, and the angle between them given to you. Use the formula QVB sine theta. Try to find out the value of the magnetic force. And the answer that you get, I would want you people to tell me the answers in the comment section. Okay, guys. Now, if you are a student who has missed the lectures which are done from electrostatics, capacitance, and current electricity, then how can you cover up those? For that, all you have to do is go on the channel playlist. Which playlist are you looking for? You will look for this playlist, JEEt Lo 2021, and that too, the subject-wise playlist for physics. Okay. If you are a student who's aspiring for JEE 2020, which is now happening in the month of September, guys, we have a latest crash course which is starting for you guys exclusively for the JEE 2020 students, starting on 20th of July. Okay. And if you are interested in this, if you missed out on the previous one, then you can enroll for this crash course. For that, all you have to do is follow this link which is available in the description box. Okay, look for that description box, guys, and when you will click on this link, all you have to do is put up this coupon code. The crash course, which is actually worth rupees almost 25,000, will be yours for just 2,999. Okay, guys. And there is one more possibility or one more option. If you are interested in a test series, then we have a full length test series for 10 tests, which will be conducted for JEE 2020 students. Okay. You will also get live discussion of the paper and unlimited doubt solving. If you want to enroll for this test series, then again, this is available by clicking on this description box link. Okay, link is available in the description box of this video. Go over there, use this coupon code SMTest. The test series is worth rupees 9999, that is almost 10,000. So if you use this coupon code, crash course test series will be yours for just 1399. Okay, guys. So the crash course is almost 3,000 for you, and the test series just 1399. So do take the advantage, guys. If you think that you want to use this almost a month time, which is there in your hand, more than that, if you want to use that time precisely, and if you want to get into a forced routine, you don't want to waste your time by making timetable by your own and getting confused with multiple things, just follow this routine by joining either the test series or the crash course. Okay. Also, for people who are new on our channel, there is a Telegram group that we have where we share assignment solutions, study material, and daily updates. What is happening on this channel? For that, you can use this link, which is available also in the description box, and join the Telegram channel of Vedantu JEE. Okay. So, guys, with this, the session comes to an end. If you enjoyed solving questions with me and studying the very first session of magnetism, do press this like button. Okay. Also, share with your friends. Tell your friends about the Vedantu's channel and all these lectures which are being done for JEE 2021 and 2022. Okay. And if you have not, then definitely subscribe to the channel right now and press the bell icon so that whenever your Suri Sir comes live, you get the notification. Okay, so I'll take your leave now and I'll see you very soon. Till then, keep studying, keep enjoying physics, and more importantly, stay safe. Bye bye, guys.